Okay, 7.2, rational exponents. What we're trying to do today is get you guys, again, used to different forms, and you got to begin to think in the different forms if you're going to fully understand radicals and rationals. All right, the first one is something we've done before, but you may not remember it. It's changing from exponent form when you have a fractional exponent to radical form. Anybody remember how it goes? Alex? Okay, B is the index. And what's the radicand? Just x? X to the A, right? Is the way that goes. So B is the index, and the radicand is x to the A. So when you see a problem like A there, 49 to the 1/2 power, you say the answer is 7. Because if you were to convert this, this would be the square root of 49. Now, again, normally we don't show the 1 and we don't show the 2, right? 49 to the half is the square root of 49. And again, if you're talking principal root, then the answer is 7. Technically, plus or minus 7, but principal root, the answer is 7. So 49 to the 1/2 power is 7. 81 to the 1/2 power is 9. 100 to the 1/2 power is 10. Right? 36 to the 1/2 power is 6. So what is something to the 4th power? 1/4 power, that's the same as a 4th root, right? So B would be the 4th root of negative 81. The 4th root of negative, and you know what? My bad here. This is, well, you know what? I'm not even going to do this one because I don't like the way I drew it up. I really should have used up parentheses and I didn't. Let's just leave it. Let's do the second one and let's do C because this one's clearer. Okay, so this is the square root. And again, you usually don't show the index of negative 64, right? The exponent of the negative 64 is to the 1st power. The index is 2. It's a square root. So what is the square root of negative 64? Square root of negative 64. Destiny? 8i. I. Again, we're looking at the principal root. Technically plus or minus, but we're looking at the principal root. What I really wanted in B was to have the negative out front and then do the 4th root of 81. So that was my intent. I really should have done it like that to make it clear because it's odd when it's just a negative in front of a number. Then it's hard to tell, is the number part of the base or is it not? And it's really unclear. And I should have just made it clear. Okay? All right, the point here is you got to get used to fractional exponents and thinking of a fractional exponent as a radical. That's the point. A fraction for an exponent is a radical. How about something like this? We know that 8 to the 1/3 power is 2, right? 8 to the 1/3 power is 2. What would be, I'll leave it. I was going to do a few mental ones, but I don't want to mess them up either, and they are mental. All right, let's get into this chart here, and you got to go through, and the beginning of it is we know our rules. X to the A times X to the B is, all right, so we know we're going to add the exponents. X to the A plus B. Oh, come on, Windows 7. Stop that. Right, X to the A times X to the B equals X to the A plus B. Okay, so the second example, we have this in fractional form. So, but again, it's the same situation. I'm not going to use all the color because it just gets to be a pain. But now you're adding up the half and the half, right? And you end up with x to the first or x. So x to the half times x to the half is x, right? Half plus a half is a whole. You got x to the first power, and that's x. Well, in the last scenario then, you've got the square root of x squared. Kind of reverse my colors there. Do you see that this is this? They are one and the same, right? The left example in the yellow background is using fractional exponents, and the right example is radical form, but they're the exact same thing. A square root of x is an x to the half power. So they're the same, and sure enough, they better end up the same, right? It equals x. Dolores.
If this was a number and if it was the same number, wouldn't it just equal the number?
If x were a number,
Yeah.
yes. So if it were 7 to the 1/2 times 7 to 1/2, the answer would be 7. Or if it was the square root of 7 times square root of 7, again, the answer would be 7. Exactly. Okay? All right, so second thought is division. And so again, we know the rule, x to the a times x to the b is x to the a minus b. Right? These have been on every test you had in Algebra 1, and they've been on every test you've had in Algebra 2. Okay, so second scenario, then what do we got? Can't even see it there. What do we got? 8/3 and a 2/3? All right, 8/3 and a 2/3. And again, I'm not going to use all the color because it'll drive me crazy. So 8/3 and 2/3. And hopefully you can do your fractions. So that is 8 to the 6/3. I mean x to the 6/3. Final answer, x squared. So the first is reminding us of how we're doing the exponent rule. The middle is now doing an example, and the right-hand side is the middle in radical form. All right, so we've got the cube root of x to the 8th divided by x squared. This is exactly the same thing. Because again, if you were to separate this, you would get the cube root of x to the 8th over the cube root of x squared, right? If you were to separate it. I just want to show you that they're the same thing. Isn't the cube root of x to the 8th x to the 8/3? And isn't the cube root of x squared x to the 2/3? And aren't they being divided? Okay. But again, this isn't the form that's of value to us. If we go back to this form, you could actually reduce, right? X to the 8th divided by x squared is x to the 6th. Do you agree? Right? Isn't an x to the 8th divided by an x squared x to the 6th, right? If you don't believe me, look right. I'm trying to find space. Look right here. If all you had was x to the 8th over x squared, doesn't that become x to the 6th? All right, so I'm doing the part under the radical. Okay, so then finish it. What is the cube root of x to the 6th? Of course, it's x squared. And of course, you're going to end up in the same place. One way is looking at it with the rational, using fractions. The other way is radical form. All right, the next scenario is multiplying, right? X to the a to the b, we know is x to the a times b, right? So in the second example, we got to multiply a 4/5 times a 10. Can you reduce before you multiply? Here, I better show the step or I'll lose some of you. So you got a 4/5 times a 10, and it might help if you put it 10 over 1. And now we can reduce the 10 and the 5. And we end up with what? X to the 8th? X to the 8th. Okay, so here's the relationship we want you to take away on this, and here's the concept on this one. This 10 gets multiplied times this 4. So this thing ends up the 5th root of x to the 40th. Because don't we now end up at x to the 8th? Do you agree? We do, right? Because isn't the 5th root of x to the 40th? 40 divided by 5 is 8. So what you want to learn on this one is, again, the fact that you can take this 10 exponent and multiply it right here. That's what you're trying to take away from that example. Okay? Next example. Now you got two factors as the base, right? So we know that this is going to be x to the a, y to the a, right? Any problem there? We've done that before. Because an xy to the a power, for example, if you had xy squared, it's xy times xy, right? How many x's do you get? 2, x times x. How many y's do you get? 2, y times y. If it were, I'll leave it at that. I don't want to confuse you. All right, so the second example, again, this is going to be x to the 2 times the 1/4, right? And the y to its exponent 4 times the 1/4. Does that make sense? Same thing we did on the left, we're doing on the right. Now do some reducing. Your x ends up to the half power. Your y is 4 over 4, and that's 1. You get x to the half, which is the same as square root of x, and a y. So in this situation, we've got the 4th root of x squared, y to the 4th. All right, this one, let's start off this way. We can take the 4th root of y to the 4th, right? And we all know that that is y. No problem there, correct? And so now you end up with the square, or the 4th root of x squared. All right, we say, well, how does that get me to the square root of x? If you really wanted to, let's change this to exponent form, and you get x to the 2/4, don't you? The radicand's exponent divided by the index. Yes? And what is a 2/4? A 1/2. And where do we end up at? Y times the square root of x squared. Y times the square root of x, I'm sorry. Right? Y times the square root of x. X to the 1/2 power is the square root of x. So the same place. Same place. Okay, next rule. Get this high enough for you guys. Let me go to the top and get there. Okay, so next one, if you remember, you can split this up. This is x to the a in the numerator divided by y to the a in the denominator, right? So you get a fraction to an exponent. So with our example here, take your numerator, its exponent times the outside exponent, right? And you can do the same in the denominator However, there's a little trick on this one. What's the value of an 8? An 8 is a what? 2 cubed, right? So what if we make it 2 cubed times the 2/3? Okay, so where do we end up on the top? You end up with n to the 10/3. Not very pretty. What do you end up on the bottom with? A 2 squared, right? Which is a 4. Luke?
Say if the exponent that was multiplying the whole fraction.
The one all the way on the outside?
Yeah, 2/3.
Yep.
That was like a 2/5. Would you not change the 8 to 2?
Then there's not a whole lot of value to it. I mean, you could, but it's just a different form. And sometimes that comes into a personal preference kind of thing as to, is that more simplified? Maybe. But the real question comes in, if that wasn't an 8, what if that was instead a 40? Well, now you have an 8 times a 5 times a 2 cubed. Do you want to even do anything with that? And we usually don't kind of nitpick that much. Okay, so the second example, we got to do the exact same thing. However, do you remember what we did up above? So we can do this times that, right? Remember that from a couple up above? And again, if we change this to 2 cubed, we can do that times that. So we end up with, or at least at this point, and we'll split it up, the cube root of n to the what? 10th. That's the top, right? N to the 10/3 is the same as the cube root of n to the 10th. On the bottom, you get the cube root of 2 to the 6th. What's the cube root of 2 to the 6th? 2 squared, and again, we're back to the 4 on the bottom, right? The most valuable thing of all we're trying to do right now is getting you used to knowing how to cover all the rules when there are radicals, is what I'm trying to do. And this is probably the most useful one right away, that you can multiply just toward the exponent of the radicand. All right, x to the 0, hopefully you remember, is the base divided by itself, and that's the reason it's 1. We don't need an example in the middle. Look, if you want, you could just say this is 1, right? Because it's the 5th root of x to the 4th divided by the 5th root of x to the 4th. And anything divided by itself is 1. But if you want to go the other route, you could do this. You can do the 4 times 0, right? If you wanted to. You could multiply these and get 0. And then if you change that, don't you get x to the 0 over 5? Remember, this is the main rule. The radicand's exponent divided by the index. And 0 divided by anything is 0. You get x to the 0, and you end up with 1. Again, I'm just trying to show you that it comes out the same either way. All right, I got a roll here in the last few. I don't know why you guys have trouble with the negative exponent. I wanted that to be red, actually. A negative exponent says take the base to its exponent and do it in the denominator. And x to the negative a is the same as 1 over x to the positive a. And the shortcut was negative exponent in the numerator is the positive of it in the denominator. A negative in the denominator is the same as the positive of it in the numerator. I don't know why you guys balk at that rule. It's so easy. When you take a base and its exponent across the fraction bar, you change the sign. That's all it is. You know, an x to the positive 2 is the exact same thing as a 1 over x to the negative 2. So I took it across the fraction bar and changed the sign of the exponent. That's no matter which way you go, from positive to negative or negative to positive. All right, so 49, the negative 1/2 is the same as 1 over 49 to the positive 1/2. Which is 1/7, by the way. Why in the world do I have 36 over there? I have no idea. Probably because it's easier to deal with. Why did I do 36? Let's make it 49. What in the world? So in this situation, this is 1 over the square root of 49, which again is 1/7. Okay. Last few. If you split this up, 1 to any power, any exponent is 1. I don't care if it's positive, negative, chartreuse, or whatever. On the bottom, you get 8 to the negative 1/3. We can deal with that negative and deal with everything, or we can immediately put it to the numerator, 8 to the positive 1/3. And I'm just going to leave it in that form. And so the second example, I can deal with this there, and I can deal with this there. So these aren't the same, it's just a separate example. 1 to the negative 1/3 is 1. What do you get on the bottom? You get a 24 times a negative 1/3. So hopefully you agree that that is what, a negative 8? So you get 1 over the 6th root of x to the negative 8. Change it to fraction form. Would you agree x to the negative 8 over 6? Would you leave the negative in the denominator? So then you got to put it in the numerator, right? So it's positive in the numerator, and then reduce it, and you end up with x to the 4/3. This last one, the two examples weren't the same numbers because I wanted to do with variables. And you end up with x to the 4/3. That can be confusing, I know. Just got to get used to 2 different forms. All right, I gotta roll here fast. I got a couple minutes, and I gotta finish. Okay, converting between radical form and exponent form. All right, what is a 64? 8 times 8. What is each 8? A 2 cubed, right? Everybody agree? So now it's going to be a 2 cubed over the index, right? I'm getting rid of the radical. And another 2 cubed over the index. And an x to the 6th over the index. And a y to the 9th over the index. Oops, 3. So where do we end up? 2 times a 2 times an x squared times a y. Think about, just look at your paper and think about it, right? 3 over 3 is 1, 2. 3 over 3 is 1, 2. 6 divided by 3 is 2x squared. 9 divided by 3 is 3y cubed, right? And so 4x squared y cubed. Okay, so you can do the same thing there, and I'm going to skip that for time's sake. And again, by the way, the rule was x to the a over b, right? Whether you go from exponent form to radical form or radical form to exponent form, you go either way. Okay, in this second one, we want to go the other way. We want to put this in the radical form. Because both denominators are the same of the fractions, that's the index, right? What do you have now? A 5 to its exponent, the numerator, 5 squared, and an x to the first. And you wouldn't leave a 5 squared, you would make that a 25. So in radical form, that's the cube root of 25 to the x. So again, I'm taking the denominator as the index. All right, so let me try to slow down a second here for D. So look at D. One denominator is a 5, another denominator is a 4, and a third denominator is a 2. I could make 3 separate radicals, but we don't want 3 separate radicals. We want one radical. Therefore, what must the index end up being to get one radical? Right? So some people are thinking, I need a common denominator. Because I need, and it's 20, right? Is the lowest common denominator. So you're going to multiply the first one by a 4 over 4, right, to get a 20. The second by a 5 on the bottom, whatever you do on the bottom, same on the top to get a 20. And the last one by a 10 on the bottom to get a 20. Whatever you do on the bottom, do the same thing on the top, right? We got to get this 20 denominator. Because guess what? 20 is our index, right? Now we can get it all in one radical. All right, so try to say it if you can. 2 will be to what power? 8th, right? Because 2 times 4 is 8. N will be to what power? 15. And P will be to what power? 10. And again, technically, clean up the number, punch it out on your calculator. 2 to the 8th is 256. But you got to get a common denominator to make it one radical, and we want one radical. We don't want 3 or 2. Okay? So if you're ever told to convert to radical form, I want one radical. So if you don't have a common denominator of the fractions, you got to get a common denominator. Because that common denominator is your index. All right. I was hoping to do a couple compound interest problems with you because they're fun. And it's the miracle of compounding interest, and you can figure some things out. Here's the formula. A is the total amount in the fund. If you're paying off a loan, it's the total payoff amount. If you're investing, it's the total amount that you have in the account. The formula is the principal. You guys remember that's the amount you invest or the amount you borrow. Times 1 plus R is the interest rate. And then all of that to the T, which is time. So this is a compounding formula, and it'll figure out the total amount in the account when you compound. The first example is very, very easy. So it's 8,000, right? Times 1 plus 7% is going to be, remember, always percents are in decimal form in any formula, to the 17th power. And so you're just punching that out. 1.07 to the 17th power times 8,000. So if somebody put $8,000 in an account for you at birth and we're getting 17%, when you turn 17, you would have $25,270.52. The miracle of compound interest. That's if somebody put $8,000 in an account for you. Really what we wanted to do is the second example where we're going to solve for the variable. And we're going to use radicals to do it. And I'm out of time, so you're going to have to figure it out yourself. What fun. All right, be careful. We lost a week to snow. We got to keep rolling. So be careful with your homework and try to get it figured out. All these videos are online. If you want to go back and rewatch something, they are there. If I went too fast, they're there for you.